All right, let's run through another chemistry question. This one says, like all carbonates, barium carbonate can be decomposed to the metal oxide and CO2. The delta H for the reaction of barium carbonate decomposition is 269.3 kilojoules per mole. How many kilojoules are required to decompose 10 grams of barium carbonate? All right, so to me, this just looks like a dimensional analysis problem. We're given 10 grams of barium carbonate and we want to get to kilojoules. They're asking us how many kilojoules are required. So let's start our dimensional analysis off with 10 grams of barium carbonate and think about how we might be able to get into kilojoules. So we're starting with 10.0 grams BaCO3. And the only other piece of information we have here is 269.3 kilojoules per mole. Well, we're in grams, and somehow we're going to have to use moles to use this computation. So I think it's reasonable that we would try to get from grams of barium carbonate to moles of barium carbonate, and then we should just be able to multiply by this value in order to find the kilojoules. So to get from grams to moles, the best way to do that is to use the molar mass. That relates moles to grams of a substance. So we have to calculate the molar mass of barium carbonate. Try to compute that down here. So barium, the atomic weight of barium is 137.33 grams per mole. Carbon is 12.011 grams per mole. Then we have 3 oxygens. So oxygen is 15.999 grams per mole. We'll have to do that times 3. When we add all those up, we get 197.3 grams per 1 mole BaCO3. I'm putting grams on the bottom because I want to cancel grams on the top. So now we've canceled these units, canceled the grams on top and bottom, and now we're in moles. All right, so we made it into moles, which is what we were trying to do in order to use this value here, which is kilojoules per mole. So if I put 1 mole down here and 269.3 kilojoules, we've canceled our moles, and we've made it to the unit we were looking for, which is kilojoules. So we've completed our dimensional analysis. Now all we have to do is multiply the top, divide by the stuff on the bottom, and we get our answer. So it's just 10 times 269.3. Multiplying by 1 doesn't do anything. Dividing by 1 doesn't do anything. So I'm just taking the numbers that aren't 1. So 10 times 269.3 divided by 197.3, which gives us our answer of 13.6 kilojoules.